Welcome to 5.3's Math Moment. Today students learned about analyzing and interpreting expressions and also took a look at matching them to different diagrams and models. So we're going to look at a couple of different examples today. Over here we have expressions, which remember, expressions are mathematical sentences that cannot be solved. So they do not have an equal sign next to them. We're not trying to solve these. We're just looking at them, understanding them more deeply, and matching them to the diagram. But all of these have a variable in it, or a letter, and that means we can't solve it because it doesn't tell me anywhere in the problem what those variables equal. So these are truly expressions, not equations. Equations you can solve. So we're first going to look at each expression and match them to the diagram that they represent. Alright, now it's important to know what a term is, as all of these diagrams are broken into different terms. So we have that definition here for you. It says term is a part of an expression that is added or subtracted from other parts. So if you notice inside all of the big circles on the diagrams, there's two smaller circles which represent numbers that are being multiplied together. Those go together because they are using multiplication or division, and then terms are being subtracted from other terms. So that's kind of how we break down the expression. So let's first take a look at this first one that says 12 minus 4 times, in parentheses, c plus 1. Now, anytime that I see a number and then a multiplication sign with parentheses behind it, that means that that number is going to be distributed to the rest of everything inside the parentheses, so they actually go together. I'm going to, of course, solve what's inside the parentheses first using PEMDAS, but then my 4 will distribute or multiply to that answer. So that is actually one term. They are stuck together because that's multiplication. Then 12 is a term all on its own. There's nothing that it's being multiplied with or divided with, so it is just one term all on its own. So it matches with C, this diagram down here, because I have one regular number subtracting by two things that are going to multiply together to get that product. So a number minus a product, that matches here with C. Now you might be thinking, well, the 4 and the c plus 1, but remember that whenever you solve something with a parentheses, it's going to come out as one number once you're done working with everything inside the parentheses. So this really is just like two numbers times each other to make that product. Now let's take a look at the second example. It says 7 times 8 minus 5 times d. Now, again, term says it's part of an expression that's added or subtracted from other parts. I see the subtraction sign here, and I see that these two are multiplied together, so they are kind of a set, a group, a term. All right, and then I have these two, 5 times d, that are also going to go together. The subtraction sign's in the middle, so it follows my definition. Two things that are subtracted from each other, and that clearly matches B straight across. I have two numbers inside one term, that would fit in here. Two numbers inside this term, which would fit here. They're both being multiplied together and then subtracted in the middle. So the last example is obviously A, but let's talk about why that is. Here again we see that we have a 2 times, in parentheses, e minus 3 plus 9. Now remember, similar to this term up here, anytime I have a number that's just being multiplied by whatever's in the parentheses, it's really just one term, one chunk of work, because this 2 is going to be distributed to whatever we decide the answer is for the parentheses. Let's say, just for example, that once I do all of this work, the inside the parentheses is a 6. Okay, well that one number that I get is just kind of like what's in this term, 7 times 8. Or what's in this term, 5 times d. So it really is just one term, two numbers being multiplied together at the very end. So that is why it matches this diagram. It would just be two different numbers by the time I finish with that parentheses to make one product and one term. If you have any questions about 5.3, make sure to see your math teacher.